In this video, we're going to start by reviewing some basic concepts, relationship between the graphs and solving of equations, okay? Quadratic or higher order equations. So this is a problem from a previous test from years back. It simply says it's multiple choice. The graph of this polynomial x cubed minus 2x squared minus 11x minus 12 is shown. Okay, from the graph, it's asking which of the following is not a solution to this equation. Now, this equation, of course, is basically the same: x cubed minus 2x squared minus 11x minus 12 is equal to 0. And if you just saw that equation by itself, you'd be wanting to factor it and set each of the factors equal to 0. Well, as you can determine, it does not factor, but you don't need to factor it because you have, you have the graph, and we know that if the graph is y is equal to that, then when y is equal to 0, we're looking at the x-intercepts, which are clearly at 1, 2, 3, 4, 1 to negative 3. So then you know where the intercepts are: negative 3, 1, and 4. And so you can obviously determine which it is not. Okay, it is not equal to negative 1. Okay, so that's not a bad problem at all. Okay, let me get a little bit more mileage out of that problem. Supposing I ask you, when is x cubed minus 2x squared minus 11x minus 12 greater than 0? And again, okay, you'd have to say, well, I don't know because I don't have the graph, but you do have the graph. So if it's equal to 0 when it hits the x-axis, it makes sense that it is greater than 0 when it is above the x-axis, which clearly is between negative 3 and 1, and then from 4 on out to infinity. So we could answer that by looking at the graph, okay? And by looking at the graph, we can conclude that the graph of this expression, okay, is greater than 0 on the interval running from negative 3 to 1 in union with, 4 to positive infinity. Now let me just ask one additional question. Let me say, when is x cubed minus 2x squared minus 11x minus 12, less than or equal to 0? Again, the graph is shown in blue. Less than or equal to 0 is anything where it falls below the y-axis, below the x-axis, any region where it falls below the x-axis, which is clearly in this interval from 1 to 4. But it's also, remember, this is only a partial view of the graph, then it keeps on going and going, as well as it does over here. Okay, so with that in mind, you'd have to say, well, it is up until negative 3, it's below the axis. It will never come back up again. We know that because it's a third-degree polynomial, and which means it can have at most 3 x-intercepts, 1, 2, 3, and there they are. So it's not going to come back up again and cross it, because if it does, it has to cross the x-axis. So everything that is particular to this function is pretty much shown right here. So yeah, we can say coming in from negative infinity until we hit negative 3, it is below the x-axis or less than 0. Now, because of the bar here says we want to know when it is equal, we can bracket that. And then, we can see again that it's below the x-axis in this region over here, which is inclusive of 1 up to 4. And that would be the answer to those, okay? So one thing, the graph can answer equations because the solutions to the equations are synonymous with the x-intercepts of the graph. The graph can answer inequalities because if we're looking for when the expression is greater than 0, we're simply looking at when it lies above the axes, the x-axis, okay? And when we're looking for to solve an inequality where it's comparing itself to be less than 0 or less than or equal to, we're looking for the regions of the graph where it falls below the x-axis. Okay, so we'll look at how we can resolve some of these expressions when we don't have the graph of the function to help us, and that we'll do in the next video.